In this video, I'm going to try, rather than solve a polynomial inequality, I intend to show you why we solve them in this way. So we're going to start by looking at this top option here. This is a polynomial. Notice I've not multiplied it out. We could, if we wanted to, multiply it out. Take x times x times 1, negative 3 times x, negative 3 times 1, which would get us x squared minus 2x minus 3. Multiply all that by x, we have x cubed minus 2x squared minus 3x. And we get this polynomial right here. And so what we're doing when let's look at this first one, say set it greater than or equal to 0, is we are asking for which x values. Notice, once I plug an x value in here, I get an output or a y value. So I'm asking for which x values is the y value greater than 0? Or another way to state that, looking at the graph, for which values of x is the y value above or on the x-axis? And so you can sort of see by looking at this function, starting here and going to here. From x is negative 1 until x is 0, we are above the x-axis. From 0 until 3, we're below, but then from 3 on, we are above. And we can highlight that. You can't see it on here. I'm using Desmos for this, by the way. If you move over to the left a little farther, there's a circle. We click on it, and it highlights the regions of the x-axis where this polynomial has a value greater than 0. Greater than or equal to 0. Notice these solid lines tell me it's still true when x is negative 1, when x is 0, and when x is 3. So notice what we had to do in order to solve that. Yes, I looked at the picture, but the key points were my zeros, where we crossed the x-axis, or potentially where we bounced off the axis. If we bounced off the axis, we would stay on the same side, so it may or may not give us a true boundary point. Well, let's clear that off and change it. What happens if instead we said just greater than 0? Well, we should see the same thing, except now, if I plug in a negative 1, that would turn this term into 0, so the whole thing would be 0, so we wouldn't be greater than. And it gives us dotted lines at each one of these boundary points, but it's still the same boundary points, because they are the only times when we can get from one side of the axis to the other. And what this question is really asking is, for this given function, which x values cause us to have a y value above the x-axis. If we changed it instead to less than or equal to, I'm just changing the question. For this function, what x values would give me a y value below or on the y-axis? Do we see where that would be? Well, let's highlight it. And we see that happens to the left of negative 1 and between 0 and 3. So, of course, if I want to switch it from less than or equal to strictly less than, I just make it clear that we don't include those boundary points. But notice it's still the same boundary points. It's still the same 4 potential regions. To the left of the first 0, between the first and the second 0, between the second and the third 0, and to the right of the third 0. And those are the only places where we could possibly switch, so they're the ones that we need to look at. And any one value in between will tell me. I hope this clears up why we do what we do to solve polynomial inequalities.